Topology Explorer System SI tool allows you to run circuit and channel simulation of a parallel bus and serial bus system. In this video, we will set analysis option for circuit simulation of a DDR4 SPBS. So let's get started. In the first step, we'll open the project file which you can download from the link given in the description. Then we'll open Topology Explorer 22.1. Select the Advanced SI 2 license. And once the Topology Explorer is open, you can select the file that you have downloaded and click on Open button. In the next step, we'll click over Set Analysis option from the System SI workflow, and Analysis option window will open. In the Analysis option window, we'll start from configuring the Circuit Simulation tab. We'll select Circuit Simulation tab and make sure you have selected the correct circuit simulator, which is SPD Sim in our case. Then we have to select the corner. Either we can select fast, typical or slow corner frequencies or corner parameters as per IBIS models, or you can select multiple of these. When you will select multiple of these corners, in that case, System SI will generate separate results for each corners. Alright. Then make sure you have selected the custom simulation name instead of automatic. That's it for the circuit simulation tab. Next, we are going to configure the bus simulation tab. So let's select that. In the bus simulation tab, we have couple of options. First is bus type. So make sure you have selected data lines for the bus type. Then you can select the direction. Either you can select write or read. In our case, we are going ahead with the write option. So make sure you have selected that. Then you can select or assign rank name. So in our case, rank 1 is selected by default because the SPBS topology consists of only one memory block. If we'll add couple of more memory blocks here in parallel, then it will have multiple ranks. And we can select those ranks based on the simulations. So in this case, we have only rank option because we have only one memory block. Alright. Now we can move to IO models and stimulus tab. So as we can see, it has already filled couple of default parameters. So in our case, data rate is 2.4 Gbps. Based on that, it will calculate the clock period and bit period. Let's select the number of bits, 64 bits. Then we can assign stimulus pattern, stimulus offset, and transmitter IO models. So let's assign all these parameters for controller block first. So first we have selected the lower byte of data group. And here we are going to assign a random stimulus pattern of 64 bit. Alright. So let's select that, go to define pattern. Here make sure you have selected random data pattern. Number of bits are 64. Click on preview and OK. Here we go. So we have assigned the random stimulus pattern for all the data lines from DQ0 to DQ7. Next we are going to change the stimulus offset, but before that make sure LDQS and LDQS has a stimulus pattern start from 10 and 01. Alright. So in this case it is fine. We can move to another column which is stimulus offset. In our case, we are going to assign default stimulus offset for all the lower data byte group. But in your case, if you wanted to change that, go to that edit button and from the drop down menu you can select the default stimulus offset. Next we are going to assign the IO models. So as you can see, as of now, some DDR3 IO models are assigned. In our case, we are going to simulate this topology for DDR4 IO models. To do that, you have to just select any of the data line, go to edit button, and from the drop down menu, you have to select DDR4, DQ34 and 48P. So let's go to DDR4, DQ34 and 48P, no on-die termination. And once we'll select that, it will be automatically assigned to all the DQ signals. Similarly, we'll go to the edit tab of DQS signals and let's assign DDR4, DQS 34 and 48P, no on-die termination. Alright. So we have updated the transmitter IO model for controller block. Then make sure you have selected the correct status for the signals and timing reference, which is correct for DQ and DQS signals. Next we can move to the memory tab. And here we are going to change the receiving IO model. So let's go to edit button of RX IO model column, and from there we have to select DDR4 DQ34 and 48 on die termination. Alright, and similarly for DQS we are going to select DDR4 DQS 34 and 48P on die termination. Alright, here we go. So here we have selected and assigned the RX and TX model for controller and memory blocks. So that's it for setting up the analysis options. We can close this window and save the topology. To do that, you have to go to Topology and click on Save button. In the next video, we'll add voltage and current probe points for DQ and DQS signals. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.